Alright, let's look at the homework 4.5, problem number 5. Alright, so let's sketch the graph of y equals x over square root of x squared plus 9. Alright, so first thing we would do is look at the original function. So number 1, we're going to look at the original function y. Alright, so let's find the y-intercept. So y intercept, right? Well, which means that we're gonna set x equals 0. Right? Then you can see that if you put 0, y is going to be 0. So y-intercept is 0, and x-intercept. So we set y equals 0. Alright, so we have x over square root of x squared plus 9 equals 0. But we just need to worry about making the numerator equal to 0, so x equals 0. Alright, so this just means that the graph has to go through the origin. Alright, and another thing is that we can find asymptotes. Right, it does not have a vertical asymptote because the denominator is never become 0 because it's a square and you're adding 9 to it. But it would have a horizontal asymptote. So if you do limit of this function x over square root of x squared plus 9, let's say x approaches positive infinity, right? Then we can multiply top and bottom by, say, 1 over x. Right? But there's a square. Well, 1 over x is equivalent to square root of 1 over x squared. Right? So we can combine that, then we get limit as x approaches infinity. And you have a 1 on top because x cancel out. And then you have a square root of x squared divided by x squared is 1 plus 9 divided by x squared inside the square root. Right? Then we know that here this guy, as x approaches infinity, goes to 0. Right? So therefore 1 over square root of 1 is 1. Alright, so this tells us that y equals 1 is going to be a horizontal asymptote. Alright, then there's actually another horizontal asymptote as x approaches infinity, negative infinity. Let's try. And the trick is essentially the same, but we have to worry about the sign. So when you multiply top by 1 over x and 1 over x on the bottom, right? Since x is going to negative infinity, 1 over x would be a negative number. So this would be equivalent to negative square root of 1 over x squared. Right? So this will give us a limit as x approaches negative infinity and a 1 over, right? So there's a negative sign there. And then square root of 1 plus 9 over x squared. Alright, so as before, 9 over x squared approaches 0. You end up with negative 1. Alright, so this tells us that we have a horizontal asymptote. Asymptotes, there are actually 2 of them. Y equals a positive 1 and a negative 1. Alright, so we got that. And domain is going to be all real numbers. We can probably write that. Domain is all real numbers because denominator is never 0. Right? Then we can take the derivative. So let's look at the first derivative. So number 2, y prime. Right? If you compute y prime, so y prime is going to be equal to, using the quotient rule, square the denominator, which is x squared plus 9, derivative of x is 1 times the denominator is square root of x squared plus 9 minus top is x, and the derivative of square root of x squared plus 9 would be square root is a 1/2 power, so put 1/2 in front and keep the inside function as it is, and subtract 1 from the power, so 1/2 minus 1 is negative 1/2. Then multiply by derivative of inside, which is 2x. Alright, so we can cancel 2 on the bottom and 2 on top. And since I don't like to have a negative power inside the fraction here, I'm going to multiply top and bottom by x squared plus 9 to the 1/2 power, or square root of x squared plus 9. And the same thing on the bottom so that we don't change anything. Then we get this. So this is going to be equal to, right, so if you multiply, so if you distribute this guy to the first term, oops, maybe I'll use a different color here. So distribute to this guy, we get square root of x squared minus 9 times itself, so it's going to be x squared plus 9. Right, there's a negative sign. And if you distribute this guy to that, so these are reciprocal of each other, so they cancel out. So this guy's gone. So what's left is just minus x squared. Alright, the denominator would be x squared plus 9 times the square root of that would be x squared plus 9 to the 3/2 power. Alright, then we can cancel x squared here, x squared there. We have 9 over x squared plus 9, raise it to the 3/2 power. Alright, then you can see that this is going to be always positive. 9's positive, on the bottom is positive, so this is positive, which tells you that its original function is always increasing. Alright, then we can look at the second derivative. So I'm gonna say, let's see, 3 y, let's look at the y double prime. Right, so y double prime is gonna be equal to, alright, so we can write the this guy as let's see, y prime as if we write it as a 9, then since it's sitting on the bottom, so quantity x squared plus 9, it's negative 3/2 power. If you take the derivative of that, you put let's see, negative 3/2 times 9 is negative 27 over 2. Keep the same quantity here, x squared plus 9. Subtract 1 from that, so it's negative 5/2. Then multiply by derivative inside, which is 2x. Right, so we can cancel 2 on the bottom and a 2 on top. Then you get this. Right, so it's going to be negative 27x over, right, x squared plus 9 to the 5/2 power. Right, so if you set this guy equal to 0, we can see that numerator equal to 0, x equals 0. Right, so we know that, so we can do a number line here. So here's a number line. Right, so here's x, and this is 0 right here. Right, if you look at the y double prime, right, so if say x is negative 1 or something like that, so if negative 1 here, this is positive, there's a negative, so negative negative, so you're going to have a positive sign on this interval. After 0, we know that let's try 1 or something like that, then 27x is positive with a negative sign, so this is definitely negative. And we know that the y prime is always positive, so you have a positive sign here. Alright, so this tells us that this is always increasing. Right, then we have so maybe we should draw a picture here. Alright, so we would have here, maybe I'll use this one. Alright, so the function is going to be here, increasing and concave upward. So you would have a picture, looks like that. And after 0, it's still increasing and the concave down. So you're going to have a picture like that. Alright, so let's draw the picture here. So here, I'm going to draw x-axis here. Alright, then I'm going to draw a y-axis where x equal to 0. Alright, then we have a horizontal, so we know that the graph has to go through the origin. So x-intercept is, and the y-intercept is 0. And also horizontal asymptote is positive 1 and y equals positive 1. Let's put here. Here's a positive 1. Maybe around here, negative 1. So you would have, so this is going to be the horizontal asymptote right here. Alright, so this is our horizontal asymptote, y equals 1. And there's another one down here. Alright, so this is the another horizontal asymptote. Alright, then we would have a picture. So we have to go through here, and we have a horizontal asymptote and a vertical asymptote. And we have to follow this pattern here, increasing concave up. So you would have a picture which would look like that. And here it's going to be increasing and concave down. Alright, so this would be the picture of the graph of y equals x over square root of x squared plus 9. Alright, let's see if we can find the one that looks like it, and definitely this one right here. Alright, so let's go down here, submit for testing. Alright, I came back and looks like we got the correct picture. Alright, that's it. I hope that this was clear.